So today we're going to look at going the other way around. So we'll be given the inequality, we've got to draw the graph. So the first thing is that we will ignore the inequality entirely and just go and find the line. X equals 3, well this is the x-axis, and all the lines that are x equals are vertical lines. So this would be x equals 7, x equals 3, x equals -1. And we know from what we've done before that it's not got an included value, so it's a dotted line. So that dotted line will come straight through there like that. So returning to this, it says x is greater than 3. If x is 3 here, then that's everything to the right of that, where x is greater than 3. So we can shade that area. I'm going to use this shading tool. That's not the best shading that I've ever seen. I'll try again. It's not going to be perfect, but hopefully I can get it a little bit better than that. And therefore, this area to the right is the region that we're interested in. So, to recap, first step, ignore the inequality, find the line. This is the y-axis, and all the lines y equals something are all horizontal lines, cutting the y-axis. It's an included value this time, which means that it's a filled-in line. So, it's a line going straight through there. Returning to the inequality, this says y is less than or equal to 2. All the y values that are less than 2 are all of those down here. So therefore I'm going to shade everything that's underneath the line this time. And that's the region that I'm interested in. This time we've got one of those double inequalities. So first of all, I can find the two lines, as we normally do. X equals 7 will come through here, x equals -2. There's a vertical line going through there. The one at x equals 7 though is a non-included value, whereas the one at x equals 2, and x equals -2, sorry, is a included value. So now we can return to what it says. We want x to be less than 7, so that's everything to the left of there. I'm not going to shade it in quite yet though, because I've got two inequalities to deal with. I also want x to be bigger than -2, so that's everything to the right of there. And given that I've got to meet them both, the only area that is both less than 7, but also bigger than -2 is this area here in the middle. Apologies for this going slightly outside the graph. So I've got that bit there. Okay, so now I've got a line here that isn't either vertical or horizontal. I know this because it can be written in the form y equals mx plus c. And so the easiest way for me to do this is just to look at this and work out the gradient and the y-intercept and go from there. Gradient is the number in front of x when it's in the form y equals mx plus c, which is 1. The y-intercept is the value on the end, which is the y-intercept is also 1. So if I start from the y-intercept, I know it goes through 1, and I punch on there for every 1 it goes to the right, it goes up 1 because the gradient is 1. Then that's enough. I can now draw the line on. I can see by looking at it, it's also a included value, so therefore the line y equals x plus 1 will go through there like that. And if I continue that all the way through in the other direction, it will go through there like so. So now I return to look at the symbol. I want y to be less than or equal to x plus 1, which means I want below the line. So below the line will look a little bit like this. Okay, again, first thing to do, which I forgot to write down last time, is to ignore the inequality and just focus on the line. Y equals 2x minus 3, well that's in the form y equals mx plus c, it's gradient 2. It's got a y-intercept of -3. So y-intercept is the logical start point, -3. If the gradient is 2, then for every 1 it goes to the right, it goes up 2. Like so on. And now I can see when I come to put the line on that it's a non-included value. So therefore it's going to look a bit like that. Extend in the opposite direction. Now go back to the inequality. I want y to be greater than 2x minus 3, so I want above the line. So therefore this time I'm going to shade everything that is above the line. And that's the region that I'm interested in. Now this one's a more interesting type because this time it's not automatically written in the form y equals mx plus c. So you've got two options here, and I'll show you them both. The first option is to look at this and rearrange it so that it's in the form y equals mx plus c, right? It's not that tricky this time. Because if you do, you get y equals negative x plus 7. And now you can look at it and go, well, the gradient is the coefficient of x, which is negative 1, and the y-intercept is 7. So y-intercept 7, for every one it goes to right, it goes down 1. So therefore, the line's going to come piling through there like that with the dotted line. Now there is also one other option that I think is worth mentioning at this point, another strategy that you might want to use for lines that aren't always in the form y equals mx plus c. And that's just a strategy of finding 2 points. And often using 0 can speed this process up a bit. So by looking at this and going, well, let's just say I only need 2 points to draw a line, right? If one of those points is x equals 0, if x equals 0, then 0 add y equals 7, then y would have to be 7. So one of the points on the line, x equals 0, y equals 7. You'll notice that that's that point there. And then do the exact same thing in reverse. What if y was 0? Well, if y was 0, then x would have to be 7. And you'll notice here, x is 7 when y is 0. So actually I could have just put those 2 points on there and just smashed that line in between. It's a strategy that's worth, you'll probably need it at some point just to make a few of these questions a little bit quicker and easier. So now return to the inequality anyway. I want less than x plus y to be less than 7, which means I want below the line. So I'm going to shade everything that's below this line here. Okay, so now I've got one which isn't particularly nice to graph. I could rearrange this into the form y equals mx plus c, but I'm going to get a gradient that's not that nice. We'll do it just to make a point. So I subtract 3x from both sides. That will give me negative 3x plus 12. Dividing both sides by 2 gives me y equals negative 1.5 x plus 6, which is fine, but it's not that nice to graph on this axis here. What would actually have been easier for this question is if I'd have done the two values approach, in particular using 0. Sorry, I just rubbed off the question. So if I write it back on a minute, and we go, well, if x equals 0, that whole thing is 0, y would have to be 6, because 2y has to be 12. And in reverse, if y is 0, this whole thing here is worth nothing. It's 3 lots of something to give me 12, well, x would have to be 4. And I actually only need those 2 points to plot the line, right? If x equals 0, y is 6. And if x equals 4, y is 0. And that's enough. I don't need any more than those 2 points. And that's one of those questions that is a lot easier by that approach than it is to rearrange that into the form y equals mx plus c. Now return to inequality. I want greater than 12, so I want above the line. So that's everything to the right hand side here. Okay, so this time I've got two conditions to fill. First one is the easy one, horizontal or vertical line. And this is a horizontal line going through where y is 4. It's a dotted line. Get that one on straight away. The other one is a diagonal line. It's looking like y equals mx plus c. Gradient here is the number in front of x, which is 1. The y-intercept is not present, which because technically it's 0, it's hiding around on the end. So this is just a line going through 0 with gradient 1. So we can put those two lines on, and then I'm going to read off the answer from both of those two conditions. I've not drawn that one that particularly well there, but it's going to have to do. Okay, so now we'll try and fulfill both of these conditions. First of all, I want y to be greater than 4. So if y is 4 here, then y is greater than 4 up here. And I want y to be bigger than or equal to x. If this is the line y is equals x, then everything above it is where it's greater than. So therefore, the part of the line that satisfies both of these criteria is this part here. And that's the part of the graph I'm interested in. Again, on this one, take down the horizontal or vertical line first. That's that one. And then we'll deal with the other one. The other one's set up in form y equals mx plus c here, so it makes sense to gradient intercept this. If the y-intercept is 1 and the gradient is 2, then the line is going to look a bit like that. And it's a dotted line again. Okay, so I want x to be greater than 4, so that's everything to the right-hand side of this one. And I want y to be greater than 2x plus 1, which means I want everything above this line. So that's one of those where I'm left with this tiny, tiny area here. So that is the region, I'm not even sure I can fit an R in it, that I'm interested in. Okay, so this time, looking at these, trying to do these one first, probably they're both diagonal, but the bottom one is probably the easiest. You saw this one a second ago. It's a line with gradient 1 and a y-intercept of 0. It's the big diagonal line. So let's put that one straight on here. Oh, it should have been a dotted line. You go back, do that one again. There we go. And the other one is not set up in the form y equals mx plus c, so I'm actually going to do this one by the other approach, because I think it will be quicker. So if it is x plus y equals 6, the easiest and quickest way for me to do this is just go, if x is 0, that's nothing, y would be 6. And if y was 0, x would have to be 6. Because I only need those 2 points to plot this line. You could also go the other way and write this in the form y equals mx plus c. If you did, you'd notice that the gradient would be negative, which is why this line is going downwards. And so I get this nice little picture. So now let's decide on the section that we want. So y equals x is this big diagonal here, and we wanted less than that, so that's everything to the right of this line. So it's either going to be this bit or this bit. I also wanted x plus y to be less than 6, which means that I wanted below this line. So therefore this is the bit I need to make my highlighter way bigger again. This is the bit that I want here. Okay, last one. 2 diagonal lines again. Bottom one's definitely the easiest. Y equals 2x. No sign of the y-intercept on the end, which means that it goes through 0, 0. So the gradient is 2. The y-intercept is at 0. So I only need to go like that. I can see it's got a gradient of 2. It's going to come through there like that. Let's put that line on. It's a solid line. And the other one is a little bit trickier this time. So you could either rearrange this into the form y equals mx plus c, or you could just go with 2 points. I think I'm just going to go with 2 points here. So if x is 0, oh, I've not written the question down wrong, not helpful. That's meant to say 5. Let's just rewrite this bit. X plus 2y equals 5. If x equals 0, then y would have to be 2.5. But if y was 0, then x would just be 5 itself. So if x is 0, y is 2.5. And if x is 5, y is 0. That'll do. It's enough for me to draw the line. And going the other way, like that. So now I've just got to make my shading decision. Y equals 2x is this one, and I wanted everything greater than that, so it's either going to be this one or this bit, got to be above the line. I also want x plus 2y to be less than 5, so if this is the line x plus 2y is 5, I want below that line, so therefore the only bit that does both of those jobs is this section over here.